Okay, so I got a request to do number 28 on the homework, so I'm going to do it two ways, okay? So the first way is to kind of turn your head 90 degrees to the right and try to see this as, what is it going to be? X as a function of y. So what does that mean? That means that that now x is acting kind of like the y-axis and y is acting kind of like the f-axis, and you're thinking of this as kind of a sideways function. You can actually rewrite this expression that way. See, the curve that's given here is y equals 4 times the fifth root of x. But you can rewrite that as a function of y if you just solve for x here. So if I solve for x, I get the fifth root of x is equal to y over 4. And now x is just equal to y to the fifth power over 4 to the fifth power. Okay. And now what I can do is I can integrate this from 0 on the y-axis up to 4 on the y-axis. Okay, so alpha is really 4. So that's one way to do this. So one way to do this problem is to integrate from 0 to 4 of y to the fifth over 4 to the fifth dy. Okay, and you should be able to do this, so maybe I should just stop here, huh? So now y is the variable. If you do this, you'll get the right answer. And so there's another way to do it. So if you don't like thinking of this being a function of y, you can just do it the regular way. So remember, the function that we're given is y equals 4 times the fifth root of x. So what you can see is that this is actually the area of this box with this part taken away, right? So what I'm shading in black here, this is the integral from 0 to 1 of 4 times the fifth root of x dx. Okay, and that's not exactly what we're looking for. We're looking for kind of the complement of that inside this box, right? So this area, this horrible flesh tone area, the flesh tone area is actually going to be, well, it's going to be the area of the box, which is just it's a 4 by 1 box, right? So it's the area of the box, which is 4, because that box is 4 by 1, minus the black stuff, right? So the pink stuff is the box minus the black stuff, and that's what this equation says. So another way to solve this problem is to do this, and you should be able to do that. So I'll let you do that. So those are the two approaches, and either way you do it, you should get the same answer.